Okay. First question I have. Do you guys know what type of problems these are? What are these called? Same base exponentials. Okay, and I'm making you say that because pretty soon I'm going to put out a topic list for your chapter 5 test. Your chapter 5 test is your final, by the way. They're the same thing. You don't have two separate ones. But one of the topics is going to say same base exponentials, and I wanted you to know what that was. So you wouldn't be like, surprise, what is that thing? So that's this. Okay, first, number 10. Do they have the same base? Yes, that's great news because then I can cancel the bases out. Negative n equals negative 2n plus 3. Small. Add 2n to both sides. Oh man, was it really that easy? All right. I'm not going to complain. Okay, now number 12. Number 12 is spicy. So I'm going to ask you some questions, two questions. First, do they have the same base on both sides? No. And that's basically just me asking you, is 16 and 64 the same number? Okay. What base do they have in common? And there's actually two answers. Yes. Not 8. Okay. Because what is 8 squared? And what's 8 to the 1? 8, not 16. Okay. Yes. It's 4. Okay. And you could have also said 2. 2 will also work, but 4 is easier. Okay. So I'm going to go over here. And I'm going to say, okay, 16 is 4 times 4. So 16 is 4 squared. And then 64 is 4 times 4 times 4. So 64 is 4 cubed. Okay, so 16 is 4 squared. 64 is 4 cubed. Okay, in the 16th spot, I'm going to replace the 16 with 4 squared. And I'm going to put that in parentheses and then put the negative 3n exponent still on the outside. I can't forget about him. He was there in the original problem. And then in the 64 spot, I'm going to put 4 cubed. So 16 became 4 squared. 64 became 4 cubed. Okay, now do I have the same base? Yes. Okay, so cancel, cancel. And the question is, what do I do with these exponents? Multiply them. Great. Negative 6n equals 3. Okay, so there's your 2 warm-ups for today. And the answers weren't too bad. Okay, now before you scoot your packet aside, can you look at the quiz review, please? Some very, very nice, amazing students told me that there might be questions on this worksheet. So can you take a look at it? At the quiz review, which was last night's homework? How can I help? Yes. Number 4. Okay, great. Okay. Given two terms in an arithmetic sequence, find the first 5 terms, the term named in the problem, the explicit formula, and the recursive formula. Man, I asked you to do a lot of stuff in this little space. Okay. Now, what if I took this and rewrote it 17, 72? And what if I took this and rewrote it 37, 192? Okay. Y2 minus Y1 over X2 minus X1. Does that make sense what I'm doing? So I took my two pieces of information, and this is X, Y, X, Y, and I made them into coordinates. And now I'm transferring my brain to chapter 2 to Y equals MX plus B. Okay, so what is 192 over 71? 121? Oh, Christ. It would be 120 had I written it correctly. Okay, is that better? Okay, now which point do you want to use? Me too. I'm lazy. Okay, pausing there. Are you guys good so far? I think you probably got it from here, but it's like hard to recognize that that meant coordinates. Okay, but let's keep going. So what would my equation be if we were in chapter 2? Beautiful. Y equals 6x minus 30. Okay, and what I'm going to do is change that into sequence notation to get my explicit formula. So that would be T of n equals 6n minus 30. Okay, so what did I do so far? I just found the explicit, that's it. Oh, I also need to find T of 30. Okay, so term 30 is 6 times 30 minus 30, which is 150. So the 30th term will be 150. Does everybody see what I did there? Okay, so what did I do so far? I found the explicit formula. I found the term named in the problem. I need to find the first 5 terms and the recursive. Okay. Let's do the recursive next. First term, oh, we can't do it. Can't do it without the first 5 terms. Okay, this is a critical thinking question. Okay, go slow. What is term 0? What is term 0, guys? Negative 30. Is everybody clear on the fact that term 0 is negative 30? Okay, so what I want to do is I'm going to use my other pen. And make it like that. Do you guys understand why I wrote it that way? This term 0 is not actually in the sequence. It's the number before, the number in front. Okay, so if the first term is, no, said that wrong. If term 0 is negative 30 and the growth is 6 each time, what would the first term be? And then, okay. And then I'm going to put, okay, now I'm going to do the recursive last thing. First term is negative 24. I had to write super tiny. This is what we learned yesterday, so this might be hard still. To get the next term, I take my current term and add 6 each time. Did I do everything that the question asked? Did I find the first 5 terms? Did I find the term named in the problem? Did I find the explicit and the recursive? Yes. Okay, so what I really want to remind you of is these are a lot of, these arithmetic ones are all just chapter 2. So you gotta like remember your chapter 2 slope and stuff. Okay, what else from the homework can I help with? Take a look at the front and back. I'm more than happy to help you. Five? Okay. Is it okay with you if I do both the table and the explicit equation to solve the following problem? Okay. The amount of caffeine in a person's body reduces by half every hour. If a person drinks a cup of coffee, oh, like this, that contains 200 milligrams of caffeine, how much caffeine will be remaining in their body after 5 hours? Okay. Okay, so it says that it reduces by half every hour. So what would it be after an hour? Okay, now that is a perfectly good 100% full credit answer. 6.25, find it with the table, totally fine. But for those of us that are lazy and don't want to make the table every time, I'm going to do the explicit equation. So what is the multiplier here? Okay, so my explicit equation is T of n equals 200 times 1/2 to the n. And we have not done a lot of this yet. We're doing it today also. Okay, so it's a b to the x, where a is term 0, b is the multiplier, and then to the power. Okay, and then what happens if we take it to the 5th power? Because we want to know 5 hours. And if you use the explicit equation, you can jump straight. Basically, like, I want you to think of the explicit equation as like Rick and Morty's like travel portal. You know about the portal? You guys are probably not allowed to watch Rick and Morty, but Rick, he has this gun and he like shoots it and then it makes a portal and they can go anywhere, like different dimensions and times and stuff. And that's what the explicit equation does. It like jumps you from here to there. So I don't have to like do the table all the way out. I can jump directly to 5. That's the whole beauty of the explicit equation. Okay, anyway. So there we go. So you don't have to do both of these. You just do one or the other. It just depends on what you like better. I don't care. Does that make more sense now? 2 or 2? Okay. Okay. Given the first term and the common difference of an arithmetic sequence, find the term named in the problem, the explicit formula, and the recursive formula. Okay, so is it okay with you? And for almost all of these, I'm just going to start by figuring out what the sequence would be. It's telling me the first term is negative 34. And then it's telling me that it's going down 8 each time. So it would be what, negative 42? Does that sound right? Negative 50? Okay, so that's the sequence I'm looking at. And to find the explicit, which I'm going to do first, I have to go backwards. I don't want to go backwards with black pen, though. I want to go backwards with pink pen. And find term 0. Okay, so what would term 0 be? Negative 46? 26. I don't know. Maybe I should not have had that 200 milligrams of caffeine. Okay, so my explicit is T of n equals negative 8n minus 26. Okay, does that make sense so far? Everybody see where I got the negative 8 from and the negative 26 from? Okay, now I'm going to use that portal I was talking about, the explicit equation to find the 25th number. I don't want to write this out to 25 numbers. I'm too lazy. I could, but I want to. So I'm going to plug in 25 like a function machine. Okay, so that's telling me that the 25th number out would be negative 226. Okay, last thing. First term, so you find the term named in the problem. Explicit. Okay, now recursive. The first term is negative 34. To get the next term, I take the current term minus 8 each time. You guys, I need to know your feedback. Was that helpful to go over those? Okay, so I think from the looks of it, I probably should not stamp this right now. So I'm going to start teaching today's. If you guys could please find the resource page that says this. And then set up your notebook like this. Okay, real quick, I just want to remind you guys that the quiz that you have on Thursday, we changed to a team quiz. So you get to work with your team on it. So please do not stress about the sequences. I know you're still figuring out all the notation and all of that. It'll be a really good chance to work that out, talking to other people. So do not stress. The quiz review is for a team quiz, still just practicing, okay? You guys had excellent questions, though. Okay, so for number 83, we're going to investigate three different sequences. We're going to practice making their explicit and recursive formulas for all three. However, I'm going to show you the ebook. We're actually going to use the ebook for this. The tables that are going to give you are going to start at 1, but you guys all know we need term 0 to make equations, right? So the reason I put 4 spots there is so that we make a spot for term 0. So just wanted to give you a heads up. We're going to have to work backwards. So let me help you out with that. Okay, now I want you to not write anything in the 0 spots right now. I just want you to, I'm gonna put the ebook up, and I just want you to put the 1, 2, and 3 numbers in for the moment, please. Oh, and you can go to 4, I guess. Hopefully that'll help. Okay. We're gonna start by grabbing that resource page. If you guys could please grab, after you get your tables written down, grab the resource page. Don't put the zeros in, please. Resist the urge to calculate the zeros. Grab your resource page, and we're gonna graph all three of these on this resource page. And normally I would tell you to please do not connect the dots, but we're going to connect the dots today kind of illegally. So starting with sequence A, I'm going to get you started and then I'm going to let you work on it. So 127 would be like right here. Two 54, 3 81, 4 108. I don't know why mine's so off. That's okay. Okay, when the line doesn't go through the dots, just make the dots bigger. Okay. First question. Is sequence A arithmetic or geometric? Arithmetic. How can you tell? There's two ways you can tell, one from the table and one from the graph. How can you tell from the graph? Linear, right? Okay. So, okay, and how else can you tell from the table? And I'm going to give you a hint. What's it doing? Yep. Okay. After I write this, now I'm going to go back to the resource page and graph the dots for B. I'm going to do it in different color because I'm nerdy like that. 9, 6, 381. Oh, still 381. Or 144. Oh no. Yikes. Okay. Sequence B, arithmetic or geometric? Okay, and I'm gonna say two reasons. The graph is a curve. And what is the growth doing? Times four. Okay, last one. Gonna do C. One, two, three. Okay. 1, 6, 2, 12, 3, 24, 4, 48. Hmm. Okay. Arithmetic or geometric? What is this multiplier? 2. Okay. Now I have a question. And it's kind of the same question, but in two different ways. Why did I not fill in the zeros yet? And why did I not graph the y-intercept? Yes. You're not supposed to know what they're going to be. Like you can, okay, I think what you're trying to say is You can calculate them, but they're not really part of the sequence. The sequence starts at term one. And I really want to make you guys know that when I write down the little arrow in the line, those are to help us make math models, but they're not part of the sequence. The sequence starts at number one. And sometimes we use term zero and sometimes we don't, but you're not supposed to use it in the graph. Now, I don't know if you guys saw the spoiler alert of flipping the resource page over. But we're going to go to that in a second. Okay, but the first thing I want to do here is do the explicit and recursive for each of these because I think it's really important. Okay, so for 83, we're still on 83. What is term zero in this sequence? Zero. Okay. So my explicit, and what's the power of the explicit? It's my portal. It can jump me to anywhere I want. T of n equals, okay, it's adding 27 each time. So 27 n plus 0. And if you want to be fancy, you can leave the plus 0 off, but I'm going to leave it on there because I really want you to see where that came from. Okay, recursive. And this is what we're still practicing. We just learned this yesterday. Recursive. The first term is 27. To get the next term, you take your current term and add 27 each time. Are these numbers usually the same? No, this is just a special one. Okay, before I move on, do you have any questions about the recursive? Because that's new. Okay, now this is a weird question. What is term zero for sequence B? How do I go backwards here? Okay, so this would be 2.25, I believe. Did anybody find it? Is it 2.25? I just did that in my head. Oh, look at me go on a Tuesday morning. Okay, now the explicit is going to look different because it's geometric. So you start with term 0 times the multiplier to the n. Term 0 times the multiplier to the n. Okay, but here's the really good news. The recursive never changes. So the first term is 9. To get the next term, you take your current term times 4. Okay, I want you guys to try to do C in your groups. I want you to try to find term 0. I want you to try to write the explicit and write the recursive. Give it a go. Don't look at the screen until you're ready. What do we do? Is recursive making more sense now? I hope. And even if it doesn't, it's okay, because all you have to do is figure out the two numbers that go in. Notice they're the same every time. It's just the first term number changes for each sequence, and then whatever the growth is changes. But the other symbols are always the same. So if you just memorized it, I don't know, I find that easier personally. Okay. All right, now, if you guys could find the resource page, we're last thing here today. So find the resource page that was on the back of the one we already did. And start by filling in the tables. So this is what I want you to do. I want you to fill in the tables and graph as many of these dots that will fit on the graph. So try to continue the tables, continue the graphs. I'm bad at drawing curves, I'll tell you that. Okay. Last question of the day. If these were bank accounts, which one would you want to be yours? B, definitely. Okay. And what seems to matter the most? Is it the initial amount of money? Because those are the three different types of growth. What seems to matter the most? What makes it bigger faster? The multiplier. Okay, so the moral of the story here is the curve is always going to win. If it's money, you want the curve. It's not going to happen. Maybe it is for you. I'm terrible with money. I'll buy a Squishmallow right this minute, but that's awful. Um, but if you do get the chance, you definitely want to go with something that makes a curve and not a line. All right. What is the homework? And did this? 86 to 91. And I will hold off stamping because there was a lot of you guys that had questions on that worksheet. So if you need to finish it, that's totally fine.